Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on palindrome partitioning. So the problem states that we are given a string S and we must partition the string such that each substring is a palindrome. We must return all the possible palindrome combinations. So the key observation is we are not choosing numbers, we are choosing cut positions in the string. At each index, we will decide whether to cut, check if that substring is a palindrome. If yes, then we will continue recursion. So the recursion idea is think like this. We start at index 0. From index 0 we try A, it is a palindrome, then AA, it is also a palindrome, then AAB, it is not a palindrome. So for every valid palindrome we will add it to the current path and we will recurse from next index and we will backtrack. So the base condition would be when the index is equals to the length of the given string, that means we have reached the end of the string, and that would be the base condition. So at the index we will loop from start to end and we will extract the substring from start to end and we will check if it is palindrome. If yes, we will add it to the current list, recurse from n plus 1 and we will remove it. So let's go through the code once. We need a list of string for the result, so let's call it result. Alright, now let's start backtracking from index 0. For that, let's call a method called backtrack and let's pass the start index as 0 and let's pass the given string yes, and we will pass the current list as new list for now. Okay, and we will also pass result, and at the end we will return result. Cool. Now let's implement backtrack method. Return type is void. What did we pass? We passed start index, we passed the input string, and we passed list of type string as current, and we also passed list of string as result. Now the base condition is if we reached the end of the string, then we will store that partition. So if the start index is equals to s dot length, then we will add it to the result dot add new array list of current, right? Then we will return. Now this is the base condition. Now we will try all possible combinations from start to end. So for int, let's say end starts from start index, end is less than or equals to the length of the input string, and end plus plus. Okay, now we will check if the substring from start to end is a palindrome. So if, let's write a different method, let's call it is palindrome, and let's pass the input string and we will pass start and end indices. Now we will check if it is a palindrome. If yes, then we will add it to the current string. We will explore, or we will backtrack, and we will remove it or undo it. So just our previous approach, choose, explore and undo. So yeah, for now we need to choose it, so we will add it to the current list. So current dot add of substring of start and end plus 1 because the last element is not considered. That's why we will consider till n plus 1. This is for choosing. Now we need to explore it, which is nothing but calling the backtrack function from end plus 1. And what did we pass? Current, the input string, the current list, and the result. This is for exploring. And now we need to undo. So for that, let's remove current dot size -1. Okay, this is for undo. Now we are done with this. We need to implement the helper function is palindrome. Okay, the return type is boolean because we need to check if the given substring is a palindrome or not. So we need to return true or false. So for that, what did we pass? We passed the input string and we passed start and end indices. Maybe let's call left and right. Okay, now we will compare the characters from both the ends to check if it is a palindrome. For that we need a while loop and we will start iterating. The condition would be left less than right. So if the character at left, if yes dot char at left is not equals to yes dot char at right, then we will return false. Just a basic palindrome check. And yeah, we shouldn't forget to increment left pointer and decrement right pointer. So yeah, if it came out of the for loop, then we will return true, which indicates it is a palindrome. Let's try running the code. Okay, it is accepted. I'll submit it. It is accepted. So if you consider this input AAB, initially the start is at 0, so you will pick A, and since it is a palindrome, it is added to the result. And again in the step 2 we will start from index 1. A, we will try for A, it is also a palindrome, and we will recurse from we will add this to the result, and we will recurse from end plus 1, which is B. And again we will check this is also true. Now since we have already reached the end, the base condition, since we have reached the end of the input string, then we will add this to the result. So we have added A and B. Okay, so previously we have added to the current list, and we have added this entire AAB to the resultant list. So yeah, now again we will backtrack and we will start from 0. So we will recurse, we will try AA now. So yeah, that is a palindrome. We will recurse from B, that is also a palindrome. So yeah, we will add AA and B, like since we have reached the end of the input string, we will add AA and B to the list. So the worst case time complexity would be n into 2 power n. Why? Because there are 2 power n minus 1 ways to partition, and for each partition we will check whether it is a palindrome or not. So yeah, that is it for today's video, and I will see you in the next one.